Hi, this is the video to explain how to do lab assignment 6. We pull up that assignment. The first question asks you to calculate Cronbach's alpha, the reliability value, and it asks you what does the value equal. So in step 1, it says you have to delete all of the variables that have answers that contain the answers to the survey questions that you didn't like. So I'll try to delete some of the items that I don't like. Let's imagine that I didn't like questions 1, 3, and 5. So since I didn't like those items, I'll delete them. What I do is just click on it so it highlights. Right click on the right side of the mouse and choose cut, and it'll delete it. So I click on the left side of the mouse and it'll highlight it. Then I right click and I click on cut. And I'll do the same thing for variable 5 and it'll disappear. Now I've deleted the items that I didn't want. Now I have to reverse the answers to all of the reverse score items. In order to do this, I have to go to transform at the top menu, but before I do any of this, I have to find out which items were actually the reversed items. So let's go to the San Jose State questionnaire. A reversed item is an item that asks people how unsatisfied they are with San Jose State instead of asking them how satisfied they are. So let's see which items were reversed. I am willing to transfer schools would be a reversed item because the person who answers with a 5 is least satisfied with San Jose State instead of most satisfied. If the person answers 5 to this question, they're not very satisfied with the lectures, so this would be reversed. So 3, 6. This would be reversed also. This would be reversed because if a person answers 5, they're not feeling very safe on campus. Also, I would say the same thing for this question. So let's see which items were reversed. It was 3, 6, 10, 13. 3, 6, 10, 13. 23 and 24. Okay. So what I can do is I can go and reverse those 5 items in the spreadsheet. Actually 6 reversed items. So let's go back to SPSS. This isn't the actual data set that we had because it wouldn't let me open up the data set on my computer, so I had to just type in this fake data, but it's fine because I'm just using it to show you the steps. So we go to transform, we go to recode into same variables. This is a little bit slow because of my I have a remote desktop connection that's allowing me to use SPSS. So the reversed items were 3. 3 is gone, so I don't have to worry about it. 6 was one of them. So what I'm going to do is I'm going to move all of the reversed items over into this box over here. So 3, 6, 10, 13, and the other ones were 23 and 24. If an item, if one of the reversed items was an item you deleted, you just don't worry about it. Just like how I'm not worrying about variable 3. We go to old and new values. Click here. First, I type in a 1 for old value, a 5 for new value. I add. It adds it in. So this means a 1 will change to a 5. 2 changes to 4. We have to put 3 changes to 3, even though it doesn't really make sense why we would have to enter that. SPSS still wants us to enter it anyway. And 4 becomes 1. And I'm sorry, that's not right. 4 becomes 2. So yeah, I don't want that one. We have to just pretend I didn't do that. So 4, 2, 5 becomes 1. You enter these. Every time I do this, I'm clicking on add, and it adds it in here. Then I click continue. And now it should recode all of these reverse variables that I have in here. And we'll wait a few seconds for it to do this. Okay, notice how this was reversed right here. So this is one of the reversed items. So what we can do now is, well, we've already finished all of these steps here. So now they're reversed. We now can do our reliability analysis to get the cron box alpha. So we go to Analyze, Scale, Reliability Analysis. We enter in everything from 1 all the way down to 24. And of course, the ones that you deleted won't be included because they're gone from the survey. So all of the remaining items that I didn't delete, I'm going to enter in here all the way up to 24. And I'm not going to enter variable 25 because when we did the survey, variable 25 actually wasn't one of our survey questions. It was the number of classes that students are taking. We recorded this to try to correlate it with satisfaction. So the satisfaction items only go up to number 24. So in other words, just leave off, don't include variable 25 here, leave it out. Move these over. Make sure this is set to alpha, and click on OK. So next you have to go down here. This is the important piece of output. This is our reliability value, 0.868. This is what would be your answer to the reliability question. So that would be number would be your answer to question 1. Just mention what it equals. In my demonstration here, it was above 0.70, but that might not be the case in the homework assignment. Next, we need the correlation coefficient between total satisfaction and number of classes. What we need to do first is we need to calculate total satisfaction. So we're on question 2 now. We can go to transform, compute. We have to add the names of all variables in here all the way up to 24. So this plus this. I'll stop at 24. We don't include variable 25 because it wasn't one of the survey items. We need to give this a name. We can call it total satisfaction. SPS only allows whole words. It doesn't allow any spaces between words. So we have to write this out as one word. It doesn't allow any spaces in variable names. So make sure this is entered in here. Click on OK. So it says it doesn't like my variable name. I'll try it with all lowercase. Maybe I'll just call it total. So there's something that it doesn't like. I have to make sure I have addition signs between all of these. Oh, there's one missing addition sign. That's probably the problem. You have to make sure you have addition signs between all of the variables. Okay, so now it did it. Now in my spreadsheet, it created total scores over here. What I'm going to also do is I'm going to change the name of variable 25 to number of classes, because that's what it stands for. I can click down here on variable view. I clicked right here and it'll move to the screen, and I can give each of my columns a name if I want to. Here I'll click on variable 25. I'll delete it. Or I'll backspace, and I'll type in number of classes as one word. After that, I can go back to data view. And we'll give it a title. When you're in variable view, make sure that all of these say numeric and that none of them say string. If one of them does say string, it'll cause problems. So let's go back to data view again. I'll click here, which takes me back to the spreadsheet. Now I can calculate the correlation coefficient between number of classes and total satisfaction. I click on Analyze. I go to Correlate Bivariate. Then scroll down. I move over number of classes, total satisfaction, over into this box right here. I just click on OK and it does it. The answer for the Pearson correlation between total satisfaction and number of classes is right here. When you do this, what you're going to need to do is ignore these two boxes. Ignore the top left and bottom right, because that's correlating number of classes with itself. And this is correlating total satisfaction with itself, which are meaningless. So don't pay attention to these. The ones that have the missing sig, don't pay attention to them. The Pearson correlation will be in either the bottom left or the top right. And it says 1 here, but it's not going to say 1 when you do the assignment. Make sure to take the value that's under Pearson correlation. It's not sig, so don't use this one right here. Use this one. This is Pearson correlation right here. So that answers question 3. You have the correlation coefficient. That number is just your answer. Question number 4, you have to think about. Remember that anything between 0 and 0.3 is weak. 0.3 to 0.7 is medium, and 0.7 and above is strong. And the same thing is true for negative correlations. So you just have to use that rule to get the answer. Next one is ex post facto study. So to do this one, what you're going to have to do is open up a new SPSS dataset. So this data that you were using for the first part of the project, for the first part of the assignment, is all from the satisfaction data set, which is on Canvas. But now we're actually moving away from the satisfaction data set into creating a new data set. So all of the work we've done so far would be using the satisfaction data set from Canvas. If you go to Excel, you're going to see a data set that says data set 2, and it's going to be an Excel file. You're going to want to open that up, and it'll look like this. It's going to show each of the students' names and all of this right here. What you're going to want to do is you're going to want to copy and paste all of this right here, only these 3 columns under digit, word, and recall. You can copy right here. Then you can paste it right in. I would actually paste it in column 2 right here, because you're going to need column 1 for something else. Now let's give these names. We'll call them digit recall, word recall, and this one should actually be picture recall, but for some reason it's just called recall. So let's go down to variable view. Remember, we're working with variables 2, 3, and 4. So I'll click here. It's digit recall. This is going to be the title of column 2, because here where it says name, this second one down is the title of column 2. This is the title of column 3. This is the title of column 4. Remember, SPSS doesn't allow spaces in variable names. Okay. Now what we want to call this variable is transfer status. So let's go back to variable view. Let's delete this. We'll call it transfer status. One word. And it has to be it has to say numeric, even though it's not really numeric. That's just the way SPSS wants it. Let's go back to data view. Everyone who's a transfer student will be a 1. Everyone who's a non-transfer student will be a 2. So starting off, it'll be 1, 1, 1, 2, 1, 1. Then it'll be 2, 2, 2, 1, 2. We're just coding people as transfer students and non-transfer students. We collected this data in class. Then everyone after that is a transfer student. So 1, 1, 1, 1. Now we can answer some of these questions. It says, what was the mean recall score for visual learners? What was the mean word recalls for auditory learners? Actually, what happened here is we didn't have enough visual learners and auditory learners to actually collect that data. So instead of recording people as visual learners and auditory learners, we recorded whether students were transfer students or non-transfer students. So you just have to replace this with transfer and this with non-transfer. And instead of having learning style as a variable, we had transfer status. So what it's asking is, what was the mean recall score for transfer students? What was the mean word recall score for non-transfer students? Which group performed better, and was the difference statistically significant? What we have to do is we have to go to Analyze, Compare Means, Independent Samples t-test, which is a t-test, meaning a test comparing the means of two groups of people. The grouping variable is transfer status, so move it here. Click on Define Groups. We coded transfer status as 1s and 2s. So group 1 is a 1. Enter that here. Group 2 was a 2. Enter that here. Click on Continue. Next, we're doing word recall first. So click on word recall. Move it over. Click on OK. This tells you the mean for transfers and non-transfers. Remember that I made up this data, so this isn't real, so your answer will be different than mine, but according to my data, non-transfers did better than transfers because this mean is higher than this mean right here. So these are the two means for transfer and non-transfer. You can see that non-transfer did better, but now we have to check to see if the difference is significant. To do that, we have to go to the bottom table. Scroll all the way over. Ignore this sig right here, we don't need that. We go to sig two-tailed. Go to the bottom one down here. This right here is your p-value for statistical significance. It's a significant difference if it's 0.05 or lower. If it's above 0.05, it's not a significant difference between the two means. Now, what the next questions are asking you to do is to do the same thing over again, but for picture recall and digit recall. So what we do is we just go back here again, go back to compare means, independent t-test. We switch word recall for digit recall, move it over, we click on OK. All we did was switch them over, and we get the same thing again. Now you just answer those same questions again for digit recall. You get the two means, you look at which group did better, and down here, you look to see if it was significant. It's the sig two-tailed, the bottom number right here. You do the same thing again, compare means. Now we switch digit, click on digit recall, move it back, switch it for picture recall, click on OK. You get the same thing over again. That's what you have to do for this section right here. Questions 1, 2, and 3. And so we finished section 2 of this assignment. This section is asking you to do matched pairs. And in order to do this, we actually need a new data set. So we go to File, go to New Data. If you do this on your computer, you just have to try to save your work before you do this, before you click on New if you want to keep the old data set, because it might erase it. So what you do now for part 3 is go back to variable U, for this is the first name, so you actually need to do digit 1, digit 2, word 1, word 2, picture 1, and picture 2. Make sure there's no spaces. Now we go back to data view. What we now need to do is each row will be data from one matched pair of people. So you'll have to go to someone in the class and ask them what the matched pairs were. But let's just say that I'm just guessing. Well, let's assume that Marianne is matched with Melody, or Isabel and Sun were matched. They actually weren't matched, but let's say they were. Isabel was actually matched with someone else. So we're saying that Isabel is person 1, Sun is person 2, and they're the first pair. We enter Isabel's data 444 under digit 1, word 1, and picture 1. So Isabel's data goes right here, 4, 4, 4, and then Sun's data goes under, she's person 2 in the first pair, so she goes under digit 2, word 2, picture 2, so 2, 3, 4, right here, 3, 4. Now we go to our next matched pair. Let's say that Amanda and Marianne were matched together, even though they actually weren't. It means in the second pair, Amanda is person 1, Marianne is person 2. So Amanda's data will go under digit 1, word 1, picture 1. So hers was 2, 2, 3. And person 2, which was Marianne, her data will go under digit 2, word 2, picture 2. So hers is 2, 4, 2. Here, here, and here. So this row is our first matched pair. It's Isabel and Sun. This is our row 2 is our second matched pair, which is Amanda and Marianne. You'll just keep going down until you've done it for all matched pairs. And you should end up having 8 rows, because we'll have 8 pairs of 2 people. I'll just skip ahead because you know how to fill it down into row 8. Once you've entered it all down into row 8, what you'll do next is you'll go to Analyze, you'll go to Compare Means. This time it's a paired samples t-test because of the matched pairs. So it'll say pair 1, you'll enter digit 1 and digit 2 as one pair. So you're comparing digit recall of transfer students and non-transfer students. Word recall will go here. Word 1, word 2 will go here. So it's 1 and 2 again. Picture 1 is here. Picture 2 is here. After you have 1, 1, 1, and 2, 2, 2, like this, click on OK. Now you'll have your means in here. These are the means that you need. So where it asks you here, it says, what was the mean word recall score for transfer students? What was the mean word recall score for non-transfer students? And which group performed better? you can get that for word recall by going here, word 1 and 2. This is the mean word recall score for transfer students. This is the mean word recall for non-transfer students, because 1 is transfer, 2 is non-transfer. So it looks like for word recall, non-transfer students did better than transfer students, because that's what the two means are showing. And to find out if the difference here between transfer and non-transfer was significant, you have to go down here to the bottom table where it says paired samples test, not correlations. So pair 2, word 1, word 2, scroll all the way over, go to SIG, right here. This is for word recall. So if the p-value is 0.05 or lower, it's a significant difference. If it's above 0.05, it's not significant. Go back up here again. This is the mean picture recall for transfer students, and this is the mean picture recall for non-transfer students. According to my data, transfer students did better than non-transfer. And to check for significance, go to picture 1 and picture 2. Go over here, check the p-value. If it's 0.05 or lower, SPSS calls p-values sig values. And you will do the same thing again for digit recall. According to my data, this was the mean digit recall for transfer. This was the mean digit recall for non-transfer. Transfer students did better than non-transfer students because their mean was higher. And if I go to digit recall, pair 1, I check the p-value, it's above 0.05, which means it's not significant. Remember, you check for 0.05, not 0.5. So 0.5 is definitely above 0.05, so it's not significant. So that answers questions 1, 2, and 3. How did the results change after using matched pairs? So I just want you to describe a little bit if the results changed from part 2 of this assignment when you were doing the independent samples t-tests to part 3 when you were doing the paired samples t-tests. What was the purpose of doing the matched pairs? Well, we were matching people on hours of sleep, and the purpose of it was so that we could match two people together with similar amounts of sleep. So in each matched pair, we had 2 people who slept about the same amount. So if a certain matched pair shows a difference between person 1 and person 2, we know that that difference wasn't because of sleep. So it's pretty much allowing us to look at the difference between transfer and non-transfer students without having sleep being a confounding variable. Was this study an experiment? You have to think about what we're comparing. We were comparing transfer and non-transfer students, and a study is only an experiment when the participants have been randomly assigned to the groups. So think about whether I randomly assigned half of the students to be transfer students and the other half to be non-transfer. So did I randomly assign people to be 1s and 2s and tell the 1s that they have to be transfer students and tell the 2s that they have to be non-transfer students? If I did do that random assignment, it is an experiment. But if I didn't do that random assignment, meaning if I just compared people who were already transfer students or already non-transfer students, it's not an experiment.